they come through the floor, they're all through the floor.
Okay, cool.
And there's quite a bit of distance between the ceiling below and the floor here.
Well, they probably dropped the ceiling, didn't they? I know they dropped the ceiling here.
Did they?
Yeah, you can go upstairs and see that.
Oh, okay.
They dropped it like 3 feet.
Okay, so they have plenty of room for ductwork up
Yeah,
here.
right.
Okay. But this is
The innocuous box that you see everywhere, right?
yeah.
That's what it really means.
Mhm.
So tell us again what this is.
Okay, so this is the fan coil units that I've been talking about.
No way we can look at it
And, well,
without causing damage.
let me see if
I got a screwdriver if you need it. Huh. Well done. I got my heavy. Here we go. So this is what's behind the wall.
Yep.
Watch out, let's pull the wires to stop there.
Yeah.
Let's move that end in a little bit. See? Oh, gotcha. Okay.
Okay.
So that doesn't need a filter.
Well, it has an air cleaner right here, right?
That's the filter right there.
Okay, so you'd have to change.
Yeah.
Do you ever play around with electrostatic filters?
No, I haven't.
Some people say that they're bad for you, but it's supposed to take out a lot more impurities. I'm just curious.
Uh-huh.
All right, so there's the fan coil. I wonder where it gets its name.
Yeah. So, the chill water comes in through the left side, through the supply and a return, and there's your control valve right there.
Right.
So that controls whether the valve, that controls the water flow. If it's open, water flows through. If it's shut, then water stops.
Right.
And it's controlled by this thermostat, this wiring here
Right.
on the side.
So I see a switch there. What's that all about?
Oh, that right there?
Right here.
That's so you can work on the unit, I guess.
Okay, it just turns off all
Just
the
turn
power.
the
to it.
power to it, yeah.
Okay. But you can control whether it's heat or air conditioning from this little remote station you're talking about.
Yeah. Well, actually, the thermostat over here controls the, whether you're getting cold water through there or hot
Okay,
water.
so it automatically makes the transition.
Yeah.
Cool.
Thank you.
Not like your room unit where you have to say
Yeah.
air conditioning or heating. This
Yeah.
one will transition on its own.
And then if there's condensate, it'll drip into this pan here
Right.
and it'll drain down into here and go back down underneath the floor. And,
Which is a perennial problem. It's the little bits of water
Yeah.
that ends up getting blocked. Because that condensate water is not the cleanest in the world. It tends to get a lot of algae in it and stuff like that, which is one reason why they usually use clear pipe on it, right? So you can
Yeah.
spot it.
yeah.
And so it clogs up and backs up, and then you got a problem after a little
Yeah.
while. Just a drip or two a second after a couple of months is a lot of water.
And that's your blower, they call that the blower. The motor here turns that and pulls the air in, blows it up across the,
So
Floor.
that's the this is the heat exchange, right? Where
Yeah,
you take
that's
the
your heat
cool or the
exchanger,
water,
that's
so
right.
you blow the air through that, and if there's hot
Blow air
water
through
running
that,
through
yeah.
that, the heat is disseminated out through the air,
Yep.
or cold. So it's the same principle, just depends on what
And then it
what
blows it
flavor
up
of water
through
you're
this-
running through it.
through this panel here and out through these supply grills.
Right. Cool beans.
Air comes in there and
Comes out on your top.
Yep.
So, the things we take for granted, right?
Mhm.
There's actually a fair amount of technology behind this stuff,
Yeah, it is. Yep.
and expensive.
Mhm.
So how much does one of these units, just the one wall unit, cost for air exchange?
They're about $1,500, I believe.
1,500.
That's just
Yeah.
material.
Yeah, yeah. You gotta install it and
Yeah.
wire it and plumb it.
You
Yeah,
take
I
care
mean,
of it.
it depends on how big it is too.
Do you know how many units
That
are
does-
in Randolph Hall?
In Randolph Hall, about probably 150.
Oh, I
Yeah,
didn't expect
it's a lot.
that.
Yeah.
Whole lot of water moving around,
Yeah.
whole lot of air.
Yeah, that's right. So to replace one of these, you have to drain the water out of it first,
Yeah,
because the water's all in here.
yeah.
So if you had to replace one on the second floor, the water would have to drain all the way down from up here, down to below the second floor.
Otherwise, the water that's here will just go down to the second floor.
Yeah, you wouldn't wanna cut one of these pipes to replace this,
Right.
you know, until all the water drained out of it.
You find out the hard way real quick.
Yeah.
So it's a closed system then, except for the condensation.
It is a closed system, yep, that's right.
That's it, in a nutshell.
Mm-hmm.
So if it's not working, that means there's a leak somewhere.
Well, could be any number of reasons.
Yeah.
Right.
Yeah,
Uh,
well, if there's a leak, you'll know it,
Yeah,
cause it'll show up in the ceiling.
yeah.
So how often do you do inspections on these?
Well, someone in the building will send a work request.
Okay, so it's
Send
whenever,
work
whenever there's a problem is when you go
Whenever
out?
there's a problem, that's right.
Otherwise, no.
Well, they'll clean the air filters, This is always a little bit of a challenge. Oh,
Yeah.
let's see, I think I remember how to do it now.
Okay.
Okay.
Well, what can I do?
This goes on top of here.
I need you to come over this way.
Watch your air filter's popping out down below.
Oh, is it?
Yep.
Thanks, Rick. No, I think you need to come this way just about a quarter of an
A
inch.
little bit?
Yep.
Yeah.
See where my hand is?
Alright,
All right, you're even here.
okay.
One of us, Rich.
Makes the job more interesting, I guess.
All right, questions, thoughts, ideas? More than you knew, right? More than you thought was appropriate for preservation? Why is this important for preservation?
Depends on what it does with the pressure and the water. and,
There's that, so
all the elements
this has a
involved.
direct effect on the material around it
Yep.
and how well it's able to survive. We can look at some of the windows. Is there any of the windows available?
Yeah, it controls the humidity in the air.
Right.
And that's the main enemy, I guess, of
Well, the number one enemy of
Of
building
wood
is
and-
water.
water.
That's not
yeah.
just liquid, it's also vapor.
Yes. Yeah.
And so now it affects us on the inside, not just on the outside. So now all of a sudden our buildings have to be good on both faces.
That's true, yeah.
For one
Yeah,
way or
'cause
the other.
there's water vapor in the air, we're breathing now, it's,
Right.
So compared to duct systems, is this more efficient, less efficient energy-wise, or?
I think this is more efficient, generally speaking.
Okay.
It's certainly more efficient of space,
Yeah, yeah.
but a little bit of that depends on how big the system is. A duct system in
Yeah.
a house wouldn't make sense,
Yeah.
right?
I mean, this system.
Yeah, right.
Yeah.
Yeah, because when you're asking about efficiency, you'd have to look at the whole system. And,
Hi.
Hi, I'm so sorry.
You're fine, you're fine.
because you'd have to look at the whole system, you have to look at all the piping that comes from the mechanical room to here, and how much, how much energy you lose to those pipes with the water, while the water's trying to make its way all the way from the mechanical room to that particular fan coil unit. It loses energy, on its way. So that would be part of your efficiency.
It's complicated.
Yeah.
The main thing is that you understand
Yeah.
how complicated it is and what the factors are.
And then your motor that's running, it's pumping the water, that uses a certain amount of energy. So is that motor, moving that pump, is it efficient or is it not efficient? So that would be another part of your efficiency in the total system you have to look at.
Quite a spreadsheet before it's over with.
Yeah.
Well, my favorite story about this is back when Mark Sanford was governor. Remember Mr. Sanford, the guy who got caught on the Appalachian Trail? Anyway, he's a nice guy, by the way, don't get me wrong. Anyway, when he was governor, he was trying to do the energy efficient thing, be green and all the rest of it. And there was one whole section of the mansion which wasn't being used, and he said, to hell with it, let's turn the thermostat off, because nobody's in there, nobody's using it.
Oh, okay.
So he turned the thermostat off. 3 months later, they're faced with like a $500,000 bill to clean the mold out of it. Because it was a sealed system, assuming it was going to be air conditioned.
Yeah.
And then when you take a sealed system and cut out the air conditioning, guess what loves it? All that moisture
Yes.
is all the mold. So much for saving money, right?
Mm-hmm.
So to some extent, the way we're designing buildings now, we're designing it where the air conditioner has to be part of the factor, you know? And so for better or worse, there we find ourselves. It's not a simple turn it off and save money. Yeah. There's a question of trying to save some money, trying to make it more efficient, but we just can't pull off the grid altogether all at once.
Yeah.
Yeah. So when are we going solar?
I think they are trying to put some solar panels on campus.
Yeah, the Lassane House, the Sustainability Institute just down the road,
Yeah.
it's got solar on it. You know what all that runs?
Yeah, I don't know anything about the solar. That's
Okay.
another project manager.
Okay, well, this is cool. Thanks,
Yeah.
Matt. I really
Okay.
appreciate
All right.
the look at everything. There's our access to the attic. We will approach that a little bit later.
Yeah,
Whenever we can get it at. You wanna come along with us?
I'd be
I'll make sure-
curious to, yeah.
That ladder was downstairs.
Huh?
That ladder was in the utility
Mechanical
room.
room, yeah, there was a
Well,
ladder.
we need a 15-foot ladder. Was it tall enough to reach that ceiling?
Yeah, I think it was an extender, like extender.
Well, I'll stand on it and I'll pull people up. I'm
Yeah,
tall
right,
enough.
yeah. The safety officer would love it. Yeah, no, I used to take students up there almost every semester. Then they closed this down. Huh? Yeah.
Okay.
The thing you have to watch out for when you go up there is everybody always bangs their head on one of those big beams, and I can tell you they don't move. So as we were sitting here thinking about this building and how your response might be to this, what kinds of things did we talk about today that's worth, noting in your journal? John, you had some great points about contract, right?
Right, I think that we can see that by using that process or mechanism,
Yeah.
it actually affects the end result. And so we don't just have somebody thinking about what you want to do and then slap a regular old fixed price contract on it. We tailor the contracting type
Yeah.
and even the process. Do you ever have times where you have meetings with the potential offerors in advance and get some feedback? I guess the engineers have interactions, don't they? And is that formal or informal?
That's part, yeah, but there are meetings held, with the contractors, and then they'll submit their proposals.
And questions maybe sometimes?
And then you look at their proposals and you say, okay, you compare it to this other contractor's proposals, and you just have to weigh them out, who's got the best proposal.
Yeah, getting ideas from all sides.
You eventually gotta stick, select one contractor.
Is it low bid?
Now that is not, no, I don't think that's low bid.
Yep,
No,
see, there's another
That's
It's
example.
kind of best value, I think, is the term, price and
Yeah.
other factors.
That's right.
And sometimes in the RFP, you'll request for proposals, you'll indicate what some of the other evaluation criteria are.
Yeah.
And then you just measure it up.
Mm-hmm.
So the form of contract that they're talking about here is cool. And then comparing this system and, some of what we talked about, it's complicated, to, go ahead,
Duct system.
the duct system.
Yeah.
And you can get a feel for that, right, as you look at this and see just how much space is taken up in ducts. And,
Yeah.
there are problems with either system.
There's no way a duct system could.
No.
this building could.
No.
The only place you could put it is between the floor and
Yeah.
the ceiling.
Oh,
And
boy.
Yeah.
that would be a nightmare.
Yeah, yeah.
Well, we just tear up the building.
Yeah.
Yeah, I mean, we used a similar system to this at Circular Church, because where the hell are you gonna put a duct in a dome, So it gets to be kind of an issue.
What type of structure or infrastructure do they use in the the science?
Rita Hollings?
Rita Hollings.
That is the chill water system too. But that was not my project, but I believe they had the similar,
Right.
fan coil units,
Right.
but they are mounted up in the ceiling, I think.
So
And
the
they're
difference,
not on
right?
the floor.
The difference right now in terms of these systems is whether or not it's running off the central energy facility, right? Simmons Building's coming on, it's gonna have its own central energy facility, as I understand it, that's what they were talking about.
Right, yeah, that's their goal,
Right.
yeah. They're
So
gonna
this
build
is
a little-
another permutation
yes.
in all of this.
Mhm.
Right. So we can start talking about systems and the trade-offs from a preservation point of view and some of the complications when we start looking at long-term wear and tear on the historic fabric. And that's all something that's good to keep in our journals. Just note for the record, that, you know, when I first started working in Charleston, which was a long time ago, we were spending for the entire reconstruction of a house, what people today spend for the air conditioning. And it gives you a rough idea of just how important it's become. Not only because the technology has gotten better, but people's concern about sick building syndrome, about mold, and about efficiency has gone up. So it's all for the good, but there's been a lot of changes. Hard to keep track of it all.
It sounds like you have experience working on.
I'm not a
Old
mechanical
home
engineer, I'm a
townhouse.
landscape architect, but I've
Landscape
been around a
Okay.
fair amount of this stuff.
Yeah.
I've been involved in several maintenance projects, both for old
Mhm.
homes and for my church,
Yeah.
and worked through that. The person we had worked through the maintenance protocols for the church, they spent $300,000 for a new air conditioning system there, a chill water system.
Yeah.
He was the chief petty officer for a nuclear submarine. And it took him coming in to unpack all the system, where the noise was coming from, where the water was coming from, how the control system should work and all the rest of it. And develop something like an easy step list of how do you take care of it.
Okay.
So it gets to be kind of complicated. It was a lot of fun though.
Mhm.
All right, guys, thank you very much. I guess we're a little bit short today. Do you want to catch up with anything around campus while we're out and about?
Sorry.
Okay, thank you, Matt.
Okay.
Appreciate it.
Appreciate it.
Thank you.
Thanks a lot.